We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everyone. Today we are going to discuss about break and continue statement in C. Break statement. We already used break statement in switch statement for separating the cases. Whenever break statement encountered in a loop, the loop is terminated and control transfer to the statement immediately after the body of the loop. To understand this, we'll take the example by using flowchart. Okay, for example, firstly, our program control is given to the condition, and this condition is nothing but the condition available inside the loop. Okay, for example, if we are using for loop, then condition available inside the for loop. Okay, we'll check. Okay, if it is true, then and then control pass to the inside the body of the loop. Okay, now inside the body of the loop there is a condition, and if this condition is true, then control is given to the break statement, and if the break statement is executed, the loop will terminate. Okay, over here the loop is terminated and control transfer to the statement immediately after the body of the loop. If break statement will encountered, then the particular loop is terminated and control is given to the statement outside the body of the loop. The break statement will be executed if some condition is satisfied. It means if we are going to use break statement, we have to use it with some condition. For example, we will use some if statements. When break statement executes, all statement after that up to the end are skipped and loop is terminated. Now we'll see how the execution of break will be there. Okay, so we'll take this first example. Okay, and in this example there is a two loop. First is outer loop and second one is inner loop. Okay, so if we are using a break statement inside the inner loop, okay, if this condition is true, then and then this break statement will execute, and if this break statement will execute, then whatever will be statement over here, that all statements are skipped and control is given over here. You can check. Okay, but if we return if statement inside the outer loop but outside the inner loop, it means over here, then the if break statement is execute, then the control the statements after this if statement is keep and control is given to outside the outer loop over here. Okay, now we'll see the next statement, that is continue statement. It is also breaking statement. When continue statement executes, it keeps the remaining statements of the current iteration and the next iteration start. If we are using continue statement, one thing in your mind that the whole loop is not terminated, only a single iteration is terminate and control is given to the next iteration. Normally it is used inside if statement within the body of the loop. We'll see an example of over here. We will have a for loop over here. Inside the body of the for loop, we are using a continue statement inside the if statement. If this condition is true, then and then this continue statement will execute, and if this continue statement is executed, then whatever will be the statement over here, the statement is keep and control is given to the next iteration. This whole loop is not terminate. Okay, Now we'll see an example for it. Write a C program to display even numbers up to 1 to n. Okay, so we have a range up to 1 to n. Okay, and we have to display even number between 1 to n. Okay, I have a program over here. Firstly, we have to take number, and that number is nothing but n numbers, till when we have to find the even numbers. Okay, so I'm asking to user give last even number. Okay, then user will input the a value of n. Whatever will be the value of n, it is the last number of the even number. Okay, then we are going to print the even numbers. That's why I am writing a message over here, that is even numbers are. Okay, after it I am using while loop. We have to understand the concept over here. We are writing like this: while inside it we are writing 1. Okay, it means in any computer language, meaning of 1 and 0 is 1 is for true and 0 is for false. Okay, so over here we are using 1. Okay, it means it will always be true. Okay, so the statement written inside the while loop will executed again and again and again. Okay, so it may be possible that this loop will be an infinity loop. Okay, to stop our program we have to use break inside this loop. Okay, so how can we do it? Okay, for that I write like this. Inside the body of the loop I'm writing like this: if I modulo 2 equals to 1. I'm not using 0 over here. Okay, so 1, it means it will be odd number. Okay, if I'm using 0 over here, it will be even number. Okay, if it is odd number, I just increment the control variable. Okay, I already use I over here. I just increase the value of I. So in next iteration the value of I will be used. Okay, now I am using continue statement. Okay, now when this continue statement will execute, what happens? Whatever statement inside the loop after continue statement, it means this all statements are skipped. Okay, and control is given to the next iteration from here to directly here. Okay, continue statement will not terminate the loop. To terminate the loop, if I greater than n. Okay, if this condition is true, then we are using break statement. It means if number is greater than our inputted number. If for example I am entering 20 over here. Okay, then if the value of I will be greater than 20, then this condition is true, and then this break statement will execute. And if this break statement will execute, whatever statement inside the loop is kept, and control is directly given to over here outside the loop. Okay, now we have remaining the concept of even numbers. Okay, if number is not odd number, then number is even number. So over here we'll directly print printf percentage d slash n comma I. Okay, so this statement will execute, or this statement will print even numbers, and then we have to increase the value of I for next iteration. Okay, now, this statement will not execute in each case. This statement is only execute when numbers are even numbers, because if numbers is odd numbers, then we are using continue statement, and continue statement puts our control into the next iteration. Okay, after that if number is greater than our entered number, then our loop will be break, and control is directly given to outside the loop. Okay, so whenever the even numbers are there, then this condition is false, this condition is for also false, and then these two statement will execute. Okay, I'm executing this program. Okay, so output will be like this. Okay, given last even number, I'm entering 20 over here. Okay, and it will give output like this. Even numbers are 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, that's it for this example. now we'll see one more example, and this example we will see by using turbo C++. Write a program using for loop construct which prints all prime numbers between 1 to 50. We'll start with the first, that is what is prime number. Okay, so prime numbers are those numbers which are only divisible by 1 and itself. Okay, so what it means? Okay, so a number, for example, if we are talking about 17, okay, then we can say 17 is a prime number because 17 is only divided by 1 and itself. If we are going to implement such thing into C, then we have to think differently. We have to think vice and versa of this situation. So how we can do this? So for that we have to think about remaining number between 1 and itself. In case of 17 we have to leave the number 1 and itself, it means 17. In a remaining number we have to take, for example, 2 3 up to 16. If this number, it means 17, is not divisible by these all numbers, then and then we can say this 17 number is a prime number. Okay, so a number that is only divisible by 1 and itself is known as prime number. Okay, so how can we implement such concept into C? For that, if I will give this if I will consider this 17 as I, okay, then I have to check if I is divisible by 2 or not. Okay, for that I will do I modulo 2 and I will check. If it will not give any reminder, it means reminder value of 0, then we can say it is not prime number because the number is only divisible by 1 and itself, then and then we can say it is prime number. Okay, so then we have to check for this I number with modulo 3. Okay, and likewise we have to do up till n minus 1, or we have to check up to I minus 1. If I is divisible at least 1, or I will give at least one time 0 reminder, then that particular number is not prime number. Okay, for example, if we are talking about 4, we know 4 is not prime number. Okay, so how can we decide it? For example, we have to leave 1 and itself, so for that we have to check for 2 and 3. Okay, so in first condition we have to check 4 modulo 2. Okay, it will give 0 reminder, so we can say that it is not prime number. Okay, now we'll take the example of 9. Okay, in case of 9 we have to leave the number 1 and 9, so we have to check for 2 3 up to 8. Okay, now in case of 9, okay, firstly it is checked with 2 9 modulo 2, it will give us a reminder and this reminder is 1. Okay, then in next iteration the value is increased and it will be 9 modulo 3, so it will give us no reminder, so reminder value is 0. In this case 9 is also not prime number. But in case of 17, if we take the modulo operation with 2 to 16, in each and every case it will not give us a 0 reminder, so we can say 17 is prime number. Okay, now we'll implement this concept. For that, firstly they have given us a range, and this range is nothing but it is 1 to 50. So we have to take two loop. First loop is for this range and second loop is for number 2 to I minus 1. Okay, so I have to write over here I equals to 1, I less than or equal to 50. Okay, then I have to go for next loop, that is the inner loop, that is with control variable j, and we are initiated that inner loop from 2, and we are ending this loop up at I minus 1. As we are decided, we have to leave a number and a number, it's 1 and number itself. Okay, so outer loop is for 1 to 50 and inner loop is 2 to I minus 1. Okay, how we can write a condition for a prime number? So that is also we are decided, that is I modulo number. Okay, I modulo number that is inside the inner loop. Okay, so for that we are using I modulo j. Okay, so for that, if I modulo j equal to 0, then we have to set the value of flag by 1. Initially we'll set value of flag over here as 0. We have to set this value inside the outer loop but outside the inner loop. Okay, now inner loop will end over here. Okay, now after the inner loop and inside the outer loop, we have to check if flag value is 0 or not. Okay, this flag value is when set to 1 when this condition is true. It means at least a single time 0 will return. It means at least a single time reminder will be 0. In such case flag value is set to 1. It means that this number is not prime number. In such situation we will set flag value as a 1. If the flag value is 0, then and then our number is prime number, because if flag value is set to 1, then that number is not prime number. It means that our flag value is remain 0, then and then it is prime number. So we'll print the value of I over here, because we have to print prime numbers between 1 to 50. Okay, after that we have to go in next iteration. So from here we have to go for next iteration, and in next iteration value of I will be increased. Okay, and then we have to reset the value of flag to 0. Okay, if the value of flag over here is set to 1, then we have to reset the value of flag to 0, because we have to check for the next number. Okay, for example in second iteration our number will be 2. Okay, then it will be 3, 4, 5. So we have to check for all numbers between 1 to 5, so we have to reset the value of flag by 0. Okay, and over here loop is end. Okay, now over here I am using the break statement. Why I am using break statement inside the inner loop? Okay, over here, so I am using this break statement if we are taking the example of 9. Okay, so if we are talking about 9, then 9 is firstly checked with 2. Okay, it will give a reminder, and that is 1. Okay, we can't say up till 2 it is a prime number or not. In second case we'll use 3 and we'll check 9 modulo 3, it will give us 0. So we can decide over here that 9 is not prime number. Okay, so why we go for 4, 6, 7 and 8? So we can stop our program over here. That's why I'm using break over here. Okay, so I will write break immediately after setting the value of flag. Now we'll see the demonstration of this program into Turbo C++. Okay, so we'll start demonstration in Turbo C++. Okay, I already mentioned the header file. I already mentioned the main function. We'll start with the declaration of variables. Integer, we have to use two control variable for two different loops, I and j. Then we have to take a variable that is for flag. Okay, now I am using function for clears the screen, and that is clr ser. Okay, then I will print a simple message that is prime numbers between 1 to 50 are. Okay, and then I am using slash n, so the prime numbers will print in new line. Okay, after it I am starting with the for loop. For I equals to 1, we had given range up to 1 to 50. Okay, so we'll do for I equals to 1, then I greater than and equal to 50 and I plus plus. Okay, then inside this for loop we have to reset the value of flag. Okay, for that we have to do flag equals to 0. Then we have to use inner loop, that is for j equals to 1. Okay, then condition for it is j less than or equal to I minus 1. Okay, over here we have to initiate the value by from 2. Okay, we already discussed about it. Then j plus plus. Okay, now inside this for loop we have to check for particular number is prime number not. For that we have to use I modulo j. Okay, we have to check the remainder. If at least once the remainder is 0, then that particular number is not prime number. To do that we have to set our flag to 1. Okay, initially our flag is 0. Okay, and immediately after it, if that particular number is not prime number, then we immediately break our loop. Okay, now outside this is inner loop, and inside this outer loop will check that if flag equals to 0. If flag is 0, then we can set that particular number is prime number, because if flag is 0, it means that uh, uh, there will be no single reminder which gives 0. Okay, it means that that particular number is prime number. Okay, and in this situation only flag will be 0. Otherwise, if at least once a reminder will be 0, that flag will be 1. Okay, so if flag's value is remain 0, then we can say that particular number is prime number. So we'll print over here that particular number by percentage d. We have to use space over here. Then okay, we'll print the value of I, because we are checking the I is prime number or not. And after this outer loop we'll write get ch. Okay, that's it. Now we'll save our program by pressing F2. Then we'll compile our program by pressing Alt F9 to check there is some error or not. Okay, so there is no error. Now we'll run our program by pressing Control F9. Okay, and it will give us a prime number between 1 to 50. Okay, that's it for this lecture. Thank you very much.